Hello, welcome to my channel. Today, hello, welcome to my channel. Today I'm talking about Thevenin analysis for circuits with dependent sources. So dependent sources are the voltage or current sources that are parametrically dependent on the circuit element of the circuits. Uh, what is important is we need to pay attention to this issue. We should not short circuit any of the dependent voltage sources. And we should not short circuits. We should not open circuits the dependent current sources. So these are the key things we need to pay attention to. So somewhat the Thevenin analysis for circuits with dependent sources are slightly different from the conventional Thevenin analysis. So to begin with, I would like to show you an example. So this is the example I would like to walk through with you. We are going to find the Thevenin equivalent circuit for this circuit. So this circuit has the independent source, and it also has a dependent source. The current here is 0.2 times V naught, where V naught is this voltage. So the easiest thing we can do is to apply Kirchhoff's voltage law. Kirchhoff's current law to node A. So this is node A. We are going to apply Kirchhoff's current law to here. And you can see we have three currents. 20 amp, and we have also got another source of currents from this dependent source, 0.2 times V naught. And more importantly, we have another current given by this branch. And to be able to find the current of this branch, all we need to do is to find the ratio V naught divided by the impedance here. So essentially, the current of this branch can be calculated by V naught divided by 8.34. So by Kirchhoff's current law, the sum of directed currents towards the circuit nodes should be equal to 0. So we apply Kirchhoff's current law to node A. So node A is here. And we come up with an equation which represents the sum of currents going towards this node. This one, 0.2 V naught, plus this one, 20, plus this current, V naught, divided by 8, plus 3 times 4. Okay? And we resolve this equation with one unknown, one equation, we should be able to solve the equation for the unknown. So here we go. After some manipulation, you get the value of V naught, which is equals to this one. Now, with V naught, this is enough for us to find the voltage across A and B. And the voltage across A and B is actually the Thevenin voltage. So what we need to do is we carry on, we use the current through this branch times the impedance here to get this voltage. The current through this branch is 0.2 V naught. And remember the direction. The direction should be anti-clockwise, but the voltage is opposite. The voltage should be in the clockwise direction. So 0.2 times V naught and times the impedance here, 4 minus J2. And then plus the other voltage. Remember, the voltage, we assume the voltage in a clockwise directions to be positive. But the voltage V naught here is in the opposite direction. So we end up with minus V naught. And the total sum should be equal to 0. So we use Kirchhoff's voltage law. And this is what we get. After some resolution, we just need to know V naught. But V naught has already been obtained from the previous step. So here we go. The final answer for the Thevenin voltage should be equal to 29.4. And then the angle is minus 107 degree. So now the next step is going to be the Thevenin impedance. But unfortunately, we cannot find it straightforwardly by opening circuits of all the dependent current source. The independent current source should be open circuit, but not the dependent one. So we have to find it in different way. So what we can do is we connect a voltage, the current source here with 1 amp at the output. And in order to find the ohmic, the Thevenin impedance, all we need to do is to find the voltage here. The voltage here, V of A, divided by current 1, is the Thevenin impedance. So this is the trick. So we are going to redraw these circuits. So this is the redrawn circuits. And we have add one current source at the output. The current source that we are going to add at the output terminal is just 1 ampere. So eventually, the Thevenin impedance that we can get will be equals to V of A divided by the current here, 1 amp. So eventually, the voltage that we can get is from this node here. So assuming that the circuit is ground, is the Thevenin impedance. So let's have less distraction. So the first step is to open circuit all the independent current sources. So this one is going to be crossed out. So it's open circuit for this one. So the next step is to find the voltage V0 by using Kirchhoff's current law at this point here. There is no current here, so one current 0.2 times V of 0 pound. Another current is here. This current is 1 ampere, as you can see here. And this current is equal to V0 divided by, V0 pound divided by A plus 4J. So we have got one equation. So with one equation, we shouldn't have any problem of finding the unknown. We have only one unknown. One unknown, one equation. This should be enough. So if you solve this equation, you will got V of V0 pound equal to this value. V0 pound minus 3.24 minus J times 0.54. So now you get the V0 and you got the impedance here, and literally you know the current here. The current flowing in this branch should be continuously equal to the current through this impedance. So this is one way to find the current. Another way to find the current is to use this source. These two, the combination of these two currents, 1 plus 0.2 V0 times all the impedance here. Then you will get the voltage VA. So I'm going for the easiest way. Yeah, we find the total current here. The total current flowing through all these passive elements should be equal to 1 plus 0.2 V0 pound. Okay, so this is the next step that we are going to get. 0.2 V0 pound plus 1 times all the impedance around the road, which is A plus J4, which is this impedance. 4 minus J2, which is this one. And then you just need to resolve the equation. Yeah, you need to substitute V0 to this equation, and eventually you get the value here. And this is the value for V of TH, Thevenin impedance. So uh, this is what I get. The answer is consistent with the original answer from the publisher. So the final circuit is very easy. Yeah, we just need to do this. So this is the final circuit. 29.4. So this is VTH. So if you have any question, please leave the question to the comment section below the video. Thank you very much for your attention. Thank you very much for your time. Bye bye.